Welcome to The Explainer. Today, we're going to crack open a really powerful tool from the world of machine learning. It's a predictive tool that helps us answer some surprisingly complicated yes or no questions.
So let's just dive right in with a question that, probably feels a little personal to a lot of us. Could a machine, just by looking at a couple of pieces of information, actually predict whether a student is going to pass or fail an exam?
And look, this isn't just some sci-fi hypothetical. It's a very real problem that we can absolutely tackle. We just need two key ingredients: the right data and, of course, the right algorithm.
For our problem, the data is pretty straightforward. We've got how many hours each student studied and what they scored on their last test. These are our clues, our features. But right now, that data is just a pile of numbers. It doesn't mean anything without the right tool to make sense of it.
And that, my friends, brings us to the star of today's show, the specific, specialized tool we're going to use to turn all of that raw data into an actual, concrete prediction.
It's called Logistic Regression. Now I know that sounds kind of technical, but let's just break it down. Supervised just means the algorithm learns from old data where we already know the answer. We have a list of past students who either passed or failed. And categorical outcome simply means it's not trying to predict a number like a score of 87. It's trying to predict a category, a label, like pass or fail.
And this is really where this tool shines. You got to think of it as a specialist. It is perfect for questions with only two possible answers. Will the customer buy something? Yes or no. Is this email spam? Yep or nope. Will a student pass? It's just not built for predicting a number that could be anything, like a house price. For that, you'd need a completely different tool from the toolbox.
So, how does it actually make a decision? Well, at its very core, logistic regression is basically a probability converter. It takes in all of our clues, the study hours, the old test scores, and it funnels it all through this neat mathematical engine called the sigmoid function. And what comes out the other side is just one single number, a probability score, somewhere between 0 and 1.
And once it has that probability score, the final step is, believe it or not, incredibly simple. It just uses a hard cutoff. If the model calculates that the probability of passing is more than 0.5, more than 50%, it predicts pass. If it's 0.5 or less, it predicts fail. That's it. That's the rule.
All right, enough theory. That's how it's supposed to work. Let's actually see how it does when we unleash it on our real student data.
The whole process follows this really logical path. First, we load up the data. Then we tell it what our clues are and what we're trying to predict. Then we split the data, which is super important. After that, we create the model, we train it on most of our data, and finally, we test it on that little bit we held back.
This code uses logistic regression to predict whether a student will pass or fail based on their study hours and previous exam score. We split the data into training and testing, trained the model, and tested its accuracy. The model achieved 86% accuracy, meaning it predicts quite well. From the output, it shows the model is slightly better at predicting fails than passes. Finally, when we tested with new students, one with 5 hours and 70 score fail, and one with 8 hours and 90 score pass.
Okay, let's just pause on this data splitting step for a second, because it is absolutely crucial. We use 80% of our student data to teach the model to let it see the patterns. The other 20%, we hide it. The model never gets to see it during training. Why? Well, think about it. You would never test a student on the exact same questions they used to study, right? This unseen test data is how we get a true, honest grade of how well our model actually learned the material.
So, the moment of truth. We've trained the model on 80% of the data, and now we've just unleashed it on that final unseen 20%. The big question is, how did it do? Did our model pass its own exam?
And the headline number is pretty impressive. The model correctly predicted the outcome for 86% of the students in that test group. I mean, getting an 86% on any test is a pretty solid score.
But, just like any test score, that one single grade rarely gives you the full picture. We need to dig a little deeper into the details to see where the model is really strong and maybe where it's a little weak.
And this little report card shows that perfectly. We're looking at a metric here called recall. So, get this, the model was fantastic at identifying the students who were going to fail. It correctly caught 91% of them. But it was a little less great at finding all the students who were going to pass, only identifying 78% of them. So what does this tell us? It tells us our model is actually a little biased towards predicting a fail. Interesting, right?
Okay, so we've graded our model. We know its strengths and weaknesses.
But the whole reason we built this thing was to use it on new, unknown data. So let's try it out on a couple of brand new hypothetical students.
So meet our two new students. Student 1 is, kind of in the middle of the pack. They studied for 5 hours and their last score was a 70. Student 2, on the other hand, is a real high performer. 8 solid hours of studying and a previous score of 90.
We feed their data into our trained model. For student 1, with those 5 hours of study and a 70, the model predicts a fail. And for student 2, with 8 hours and a 90, the model confidently predicts a pass. It works. The tool is doing exactly what we built it to do.
So, as we start to wrap this up, it's worth taking a step back and just asking, why was logistic regression the perfect tool for this particular job?
So why was this the right choice? Well, it really all comes down to fitting the tool to the task at hand. Our problem had a binary outcome, right? Only 2 possibilities. Our goal was classification. We wanted to assign a label, pass or fail, not calculate some number. We needed a category, and that is exactly what logistic regression is designed to give us.
And that brings us to our final thought. We just used a little bit of data and a clever algorithm to predict a student's future with 86% accuracy. That's a pretty powerful idea. And it really makes you wonder, if we can predict this, what other yes or no questions about our world are just sitting there, waiting for the right data and the right tool to come along and give us the answer?